There's a viral coding loop spreading through Silicon Valley that nobody's talking about. It's called Ralph Wiggum, and it's turning junior developers into AI architects overnight.
Wait, Ralph Wiggum? Like from The Simpsons? How is a cartoon character revolutionizing how teams build with AI?
Because it's not just a tool, it's an open source blueprint that makes AI agents actually reliable, and the companies using it are shipping 10x faster than everyone else.
Welcome to the AI Daily Podcast. Today's news and a deep dive to help you stay ahead in AI.
Today, we're diving into what is Ralph Wiggum.
Stick around to the end for this week's headlines. Let's dive right in.
So let's talk about Ralph Wiggum. And no, not the Simpsons character, though the naming choice here is actually pretty telling about what's happening in the AI coding space right now.
Yeah, I've been seeing this pop up everywhere. An agentic coding loop. That's quite a promise. What exactly are we looking at here?
It's essentially the open source community's answer to what I'd call the reliability crisis in AI coding tools. We've had GitHub Copilot for over 2 years now. We've got Cursor, Replit Agent, all these proprietary solutions. But enterprise teams keep hitting the same wall. These tools are brilliant one moment and completely unreliable the next.
Right. I use Copilot daily, and sometimes it's like having a senior engineer pair programming with me. Other times it's suggesting code that wouldn't even compile. Is Ralph Wiggum actually solving that?
That's the claim. What's different here is they're taking a spec-driven approach. Instead of just throwing an LLM at your code base and hoping for the best, Ralph Wiggum creates what they call autonomous loops. Basically, the AI writes code, tests it, fixes it, and keeps iterating until it meets the specification.
Oh, so it's not just autocomplete on steroids. It's actually trying to deliver working, tested code.
Exactly. And here's where it gets interesting from a business perspective. This is completely open source and community-led. No Microsoft, no venture-backed startup, just developers who got fed up with black box AI tools making decisions they couldn't understand or control.
The name, though, Ralph Wiggum. That's the kid from The Simpsons who says things like, "I'm in danger," and "me fail English?"
And that's exactly the point. It's the open source community basically saying, we don't need corporate branding. We don't need to sound impressive. We just need to build something that works. Compare that to names like Copilot or Claude. It's almost anti-marketing.
There's something refreshing about that. But let's dig into what spec-driven actually means here. Are we talking about formal specifications?
From what I'm seeing, it's more like clear, testable requirements. You give Ralph Wiggum a specification, build me a REST API that does X, Y, and Z, and it doesn't just generate code. It generates code that provably meets those requirements. The autonomous loop part means it keeps refining until the tests pass.
But wait, how is this different from AutoGPT or any of those autonomous agent frameworks we saw explode last year? Most of those turned out to be demos that couldn't handle real-world complexity.
Great question. The key difference seems to be scope. AutoGPT tried to be a general-purpose autonomous agent. It could theoretically do anything. Ralph Wiggum is laser-focused on one thing, writing code that meets specifications. By narrowing the scope, they can actually deliver reliability.
And being open source means...
Coming up, we'll dig into exactly how they pulled this off, why transparency matters so much for AI coding tools, and what this means for the entire ecosystem of AI-powered development.
So let's get into the technical meat here. How does Ralph Wiggum actually work under the hood?
The architecture is surprisingly elegant. At its core, you've got 3 main components: the spec parser, the code generator, and what they call the verification loop. The spec parser takes your requirements, which can be written in plain English, by the way, and breaks them down into testable criteria.
Give me a concrete example. Say I want to build a user authentication system.
Perfect example. You'd write something like, create a user authentication system with email and password login, JWT tokens that expire after 24 hours, rate limiting of 5 attempts per minute, and password reset functionality. Ralph Wiggum parses that into specific test cases. Can a user register? Can they log in? Do tokens expire correctly? Does rate limiting work? And so on.
And then it generates code to pass those tests.
Not just generates, it iterates. First pass might get you 60% of the way there. The verification loop runs the tests, sees what failed, feeds that back to the AI with the error messages, and it tries again. This might happen 10, 20, even 50 times until everything passes.
That sounds expensive in terms of API calls if it's using something like GPT-4.
Here's where being open source becomes crucial. You can run this with any LLM, OpenAI, Anthropic, or even local models like Llama. The community's already optimizing for cost. Some teams are using GPT-4 for the initial generation and cheaper models for the iteration loops.
But let's talk about the elephant in the room, code quality. Just because tests pass doesn't mean the code is good, maintainable, or secure.
Absolutely right. And this is where Ralph Wiggum's approach gets interesting. Because it's spec-driven, you can include non-functional requirements in your specification. Must follow solid principles, must include input validation, must handle these edge cases. The more specific your spec, the better the output.
I'm looking at their GitHub right now, and they've got over 12,000 stars already. What are people actually building with this?
The examples are pretty impressive. One team used it to generate a complete microservice with full CRUD operations, authentication, and open API documentation in about 45 minutes. Another developer created a Chrome extension from scratch, something that usually takes days of wrestling with manifest files and Chrome APIs.
What about debugging? When the AI-generated code has issues in production, how do you trace back what happened?
This is where transparency becomes critical. Every decision Ralph Wiggum makes is logged. Why it chose a particular approach, what it tried that didn't work, why it refactored something. You can actually see the AI's thought process, which is impossible with proprietary tools.
But there's got to be limitations. What about complex architectural decisions, system design, integration with existing code bases?
You're hitting on exactly why this is positioned for real-world teams, rather than individual developers. Ralph Wiggum works best when you've already made the high-level architectural decisions. It's not going to design your entire system architecture. It's going to implement the pieces according to your specifications.
So it's more like having a really fast junior developer who never gets tired and always follows specifications exactly.
That's a great analogy. And like a junior developer, the quality of output depends heavily on the quality of instruction. The difference is this junior developer can work 24/7 and gets better as the community contributes improvements.
Speaking of community, who's behind this? Is there a company, a foundation?
It's purely community-driven right now. No VC funding, no corporate backing. The core maintainers are mostly senior engineers from companies that were frustrated with existing AI coding tools. They're taking a very Linux-like approach. Build something useful, let the community drive its direction.
The commit history is fascinating. They're merging dozens of PRs daily. People are adding support for different frameworks, languages, testing libraries.
And that's the power of open source in the AI age. When Copilot doesn't support your specific framework well, you file a support ticket and hope. With Ralph Wiggum, you can literally fix it yourself or contribute training data for your use case.
Speaking of security, if I'm generating code that handles sensitive data,
Stick around. We'll give you the exact checklist for evaluating whether Ralph Wiggum is right for your team, plus what this means for the future of software development.
so let's get practical. If I'm a team lead or engineering manager listening to this, what's my decision framework here?
First question, what's your current AI coding tool situation? If you're already using Copilot or Cursor and it's working well for your team, Ralph Wiggum might not be an immediate need. But if you're hitting reliability issues or if you need more control over the AI's behavior, this becomes very interesting.
What about teams that haven't adopted any AI coding tools yet?
Ralph Wiggum might actually be a better entry point than the proprietary options. You can start small, maybe use it for generating boilerplate code or test suites. Because it's open source, you can inspect exactly what it's doing, which helps with the trust issue many teams have.
Let's talk implementation. What does it actually take to get this running?
The basic setup is surprisingly simple. It's essentially a CLI tool. You install it, configure your LLM provider, and you're ready to go. The more complex part is setting up your specification templates and verification criteria for your specific tech stack.
That sounds like it could be a significant upfront investment.
It is, but here's the thing. Once you've created good specification templates for your common patterns, you're essentially creating reusable blueprints. Need another microservice? Use the template. Need another React component? Template. The community is already sharing these, so you might not even need to start from scratch.
That's actually brilliant. It's like having architectural decision records that can automatically generate compliant code.
Exactly. And this ties into a bigger trend we're seeing. AI coding tools are forcing teams to be more explicit about their standards and patterns. Ralph Wiggum just takes that to its logical conclusion. If you can specify it clearly, AI can build it reliably.
But there's got to be a human element. Are we talking about replacing developers here?
Not even close. If anything, Ralph Wiggum makes the human element more important. Someone needs to write good specifications, someone needs to review the generated code, someone needs to make architectural decisions. What it replaces is the mundane implementation work that nobody really enjoys anyway.
It's more like changing the developer's role from code writer to system designer and code reviewer.
And that's a crucial shift. The developers who thrive in this new world are the ones who can think in terms of systems and specifications, not just syntax. It's actually raising the bar for what it means to be a software engineer.
What should teams watch for as this space evolves?
3 things. First, standardization. Right now, every AI coding tool has its own approach. We'll likely see standards emerge for how to specify requirements for AI consumption.
And the second?
Integration with existing development workflows. Ralph Wiggum needs to play nice with your CI/CD, your code review process, your testing infrastructure.
And the third?
The model layer. Right now, Ralph Wiggum is model agnostic, which is great. But as we get more specialized coding models trained specifically for React or Python or infrastructure as code, the quality gap between open source and proprietary solutions might narrow or even flip.
That's a great point. We're already seeing this with Code Llama and similar models.
Here's my hot take. In 2 years, the question won't be, should we use AI coding tools? It'll be, which AI coding tools fit our workflow? Ralph Wiggum is positioning itself as the answer for teams that value transparency, control, and reliability over convenience.
So if I'm listening to this and want to experiment, what's the lowest risk way to start?
Pick a small, well-defined project, maybe a utility script or a simple API endpoint. Write a clear specification, and I mean really clear, like you're explaining it to someone who's never seen your code base. Run Ralph Wiggum, review the output carefully, and see if it saves you time. Don't bet the farm on it initially.
Any final thoughts on what this means for the industry?
We're witnessing the democratization of AI-powered development. When the open source community can build tools that rival or exceed what big tech offers, it changes the entire power dynamic. Ralph Wiggum isn't just about writing code faster. It's about who controls the future of how software gets built.
And naming it after Ralph Wiggum? That's the open source community saying they don't need to play by Silicon Valley's rules.
Exactly. Sometimes the best innovation comes from people who aren't trying to impress venture capitalists or hit growth metrics. They just want to solve a problem. And in this case, that problem is making AI coding tools that developers can actually trust and rely on. Before we wrap up, let's catch up on this week's infrastructure news. There's a fascinating new development from Anthropic's CEO who's predicting that AI could handle full coding tasks within just 6 to 12 months. According to Final Round AI's report, this would fundamentally shift software engineers from writing code to managing AI systems.
6 months. That's an incredibly aggressive timeline. Are we talking about simple scripts or complex enterprise applications?
The prediction covers most coding tasks, though the specifics aren't entirely clear. But this brings us to another interesting development. IBM Research just released Asset Ops Bench on Hugging Face, which actually highlights how complex real-world AI applications can be.
What makes Asset Ops Bench different from other benchmarks?
It's specifically designed to test AI agents in industrial settings. Think multi-agent coordination, failure analysis, and actual operational constraints. It's bridging that gap between lab benchmarks and factory floors.
Speaking of real-world applications, there's massive money flowing into this space.
Humans and a new startup founded by alums from Anthropic, xAI, and Google just raised a staggering $480 million seed round.
A seed round? That's putting them at a $4.48 billion valuation right out of the gate. What exactly is human-centric AI?
According to TechCrunch, they're focusing on AI that empowers people rather than replacing them, which seems timely given the coding prediction we just discussed.
And speaking of Anthropic, they've just released a new constitution for Claude, their AI model. This document actually shapes how Claude behaves and responds during interactions.
It's fascinating that they're being so transparent about their training process. This constitution essentially becomes Claude's value system, right?
Exactly. And looking ahead, Redis has published their 2026 AI predictions report, emphasizing that context engines will be crucial, agent frameworks will consolidate, and AI coding assistants will truly democratize programming.
So we're seeing this convergence, aggressive timelines for AI coding capabilities, new benchmarks for industrial applications, massive funding rounds, and companies getting more transparent about AI governance.
It's all pointing toward a major shift in how we interact and manage AI systems in the very near future. That wraps up this week's news. That's our show for today.
If you found this valuable, please subscribe and share with a friend who'd appreciate it.
Drop us a comment with your thoughts on today's topic.
Links to everything we discussed are in the show notes.
Until next time.